Alright, tonight we're going to introduce you to one of my favorite things in all of math, and that's a technique called completing the square. And completing the square is a thing that's going to pop up throughout the year, and tonight we're going to use that technique to help us shift parabolas. And parabolas can be moved horizontally. Let's see if I can fit it in there. I'm running out of room. And vertically. Let's see, I think I'm going to fit this one in there. Okay, by simple manipulations of their equations. We're going to teach you some real sneaky tricks tonight that are going to help you move these parabolas. And what we're going to do is we're always going to assume that we're starting with the most basic primitive parabola ever created, and that's y equals x squared. So that's kind of like the originator, the godfather of all these other parabolas. Well, what we could do is we could pull some tricks here where you notice we went from the blue to the black graph. We shifted the blue graph to the right 4 units here, okay, and you start to see a 4 creep into that equation. And then what we did is we took the black graph and we shifted it straight down 5 units. It's the same parabola, just kind of shifted right and then left. You see we went down 5 units. You can see that 5 creeping into the equation. I'll try to explain where the 4 and the 5 came from and how they impact that parabola. Okay, we're going to do a little exploring and a little experimenting, and like I said, we're going to assume that we always start with y equals x squared, and you can see that graph has already been placed on here for you. And then what we're going to do is we're going to try to graph 2 other equations on the same axes and see if we can kind of get a feel for the pattern and how the shifting is occurring and so forth. So for the first one here in part A, I just typed it into my calculator the way that we see it. I did not FOIL it out or anything. I just typed it in the way I see it. And I scrolled up and down the table until I found the vertex at 4, 2, just looking for that pattern to change. And I ended up with 2, 6, and 3, 3, and 5, 3, and 6, 6. And what I'm going to do is I'm going to go ahead and plot those points now. And as I get those 5 points plotted, it looks a lot like this. And if I compared that to the original parabola, specifically, let's focus on the vertex. Where did the vertex go? The vertex traveled 4 units to the right and then straight up 2 units. So I'm going to describe that here. We went 4 units to the right, and then we went 2 units straight up. Okay, so that's the horizontal and the vertical shift that took place. Now we're going to try another function here. Again, I typed it into my calculator just the way that I see it. I didn't FOIL it out or anything. I scrolled up and down the table until I identified my vertex. I got a vertex at -3, -5, and then I filled in some other points. I just grabbed a couple points to the left, -4, -4, and then I grabbed -2, -4, and -1, -1. And I'm going to go ahead and plot those as well. And as I get those points plotted, I'm going to go ahead and try to graph my parabola as smooth as I can, something like that. And you can compare that to the original. Specifically, again, the trick is to focus on the vertex. Where did the vertex go? The vertex went to the left 3 units and then straight down 5 units. Again, left 3, down 5. And then we could do that. We could check every point. Left 3, down 5. We could try this point. Left 3, down 5. And we've got ourselves a pattern. So we're going 3 units to the left and then 5 units down. All right. So we're starting to kind of see a pattern taking place here. And let's still go summarize it on the next slide. So in our notebook, let's call this our shifting summary. Shifting summary. Alright, there's 4 different types of ones we're going to list. And the first category here is the horizontal shifts. Those are actually a little bit trickier, actually. We'll get the hard one out of the way first. So for horizontal, the first one is if I said, and again, this is all compared, this is all based off the idea that we started with f of x equals x squared. So if I said f of x equals the quantity x plus c squared, what I actually did is I went c units to the left. Alright, whoops, hopefully I can spell, okay. And the other option is, if I said f of x now equals the quantity x minus c squared, what I did is I traveled, or I shifted c units to the right. Oops, let's see here. Spelling has become a challenge, I guess. Anyway, so let's summarize what we just said. First of all, horizontal shifts. How do you know a horizontal shift is taking place? Well, you're going to see a number that's inside the parentheses here, inside. So horizontals are inside the parentheses. And when you see a plus sign, you're actually traveling to the left. When you have a minus sign, you're actually traveling to the right. So it's just kind of maybe the opposite of what you were expecting. Plus means left, minus means right. Okay, now let's tackle the vertical shifts. I think you're going to like these a little bit better. They make a little more sense to me. All right, vertical shifts. And again, we're basing it off the idea that we started with f of x equals x squared. So let's say, what if I have x squared plus c? What I did here, notice the c is not inside the parentheses anymore, it's on the outside. And in this particular case, we went c units straight up. All right. Option number 2 is, what if we've got f of x equals x squared minus c? In this case, we went c units straight down. Straight down. So let's summarize this one. Vertical shifts, the c is on the outside of the x squared. It's not on the inside like the horizontals were. If you see a plus sign, you really do go up. If you see a minus sign, just like your intuition leads you to believe, we're going to go down. Let's go practice these. Okay, so here's our first example here. And it says the parabola shifted 6 units left and then 2 units down. The order actually doesn't matter. We can go 2 units down first and 6 left, either way. The resulting equation would be blank. So let's see if we can write the equation. I'll walk you through some of my thoughts. As soon as I saw left, I'm thinking, okay, horizontal shift. I need to do something inside the parentheses. And left actually means a plus sign. So I'm going to say y equals the quantity x plus 6 squared. Okay, so I went inside the parentheses and I threw it was x plus 6. Then when I saw down, I was thinking, you know what? That's a vertical movement. So this number is going to be on the outside of the squared or outside of the parentheses, and down literally means I subtract, so I threw a minus 2 in there. Ladies and gentlemen, it's that simple. Okay, this time they want us to find the turning point, or aka the vertex, of our parabola. Now the original parabola that everything's based off of was the parabola y equals x squared, and his vertex or turning point was at 0, 0 to begin with. Now what kind of action are we doing? I see a minus 8 on the inside, so my horizontal movement is going to be to the right 8 units, and then on the outside there is my vertical movement. And minus 4 means I'm going down 4 units. So the vertex used to be at 0, 0. Now I'm going to go to the right 8 units and I'm going to go down 4 units. There's my new vertex right there. So I'm going to go with choice 4 on the multiple choice question. Now typically, anytime we've worked with parabolas before, they've been in the form y equals ax squared plus bx plus c. And that's what we used to call the standard form of a quadratic equation or a parabola. And all of a sudden on this video, we haven't seen any of the parabolas come in this form right here. They've all been in some weird form with some parentheses and some numbers inside and some numbers outside. Well, what we've seen so far is a form called vertex form. It makes it very easy, like we saw in the last example, to quickly identify where the vertex is just by looking at the equation and really not having to do much work at all. And for simple parabolas, if we're shifting y equals x squared, we can rewrite them in vertex form, and it's going to say y equals, ready for this? Quantity x minus h squared plus k. Alright, so I want you to kind of box that up a little bit. That's what we call our vertex form of a parabola, compared to standard form that we used to use, and where the ordered pair h comma k represents the vertex of the parabola. Alright, so that's one of the big things that we want to box in going into tomorrow's class. So far, like we said, all of the problems so far today have been in what's called vertex form. And once they're in vertex form, boy, it is gosh darn easy to find the ordered pair for the vertex. But what if it's not already in vertex form? What if they give me the equation in what's called standard form, y equals ax squared plus bx plus c? Could we convert it, or could we rewrite it in vertex form? And we're going to use a process called completing the square. So what is, just to kind of summarize here, what completing the square does is it helps me move from standard form into vertex form Okay, standard form is y equals ax squared plus bx plus c, and vertex form looks like the quantity x minus h squared plus k on the outside. Okay, so we're going to get from standard to vertex form, and the first equation here is y equals x squared plus 8x plus 7. We're going to go through this one real nice and slow, and then we'll speed it up on the next couple. The first thing I want you to do is I want you to rewrite the first term plus the second term, and then we're going to create a space here. We're going to go plus somebody, minus somebody, and then your c term, plus 7. So in our notebook, we're going to say that step 1 is to rewrite with 2 spaces in between the b and the c term. Okay? Rewrite with 2 spaces between the b and c terms. Now when I say the b term, I'm referring to this guy, and when I say the c term, I'm referring to this guy right here. So we just put 2 spaces. Notice the first one's always going to have a plus sign, and the second one's always going to have a minus sign, and that'll be true every time we complete the square. Alright, step 2. This is the fun one. Alright, and all I'm going to do just to get us started here is I'm going to rewrite what I had. Alright, what I need you to do now is I need you to take, right now your b term is an 8. Half of 8 is 4, and if I square that number, I'll get 16. And so I want you to add and subtract 16 within those spaces. Okay, first write that out. What we're going to do is we're going to take half of your b term. You're going to square that number. And then add and subtract that new number. Alright? And so you're thinking, what in the world is going on? Now technically, look at what you've essentially done. Okay? You have added 16 and you've subtracted 16, so you haven't changed the equation. You've essentially added 0 to the equation, but it's just a nice little trick that's going to set us up nicely here in our next step. Okay, step 3. I want you to focus on those first 3 terms, and I want you to factor them. And I got x plus 4 times x plus 4 because 4 plus 4 is 8. 4 times 4 is 16. We're good to go. And then I want you to combine the last 2 terms, and negative 16 plus 7 is a negative 9. And so how do we want to describe that move right there? Step 3, we're going to factor the first 3 terms. Alright, told you this was a fun trick. And notice how these are identical. These right here should be identical every single time, and if they're not, that's a red flag that we did something wrong. So let's make sure that those 2 terms are identical each and every time. Alright, next thing I want you to do is I just want you to condense those 2 terms. Let's say x plus 4 quantity squared minus 9. So we'll say that the 4th step is to condense the factored terms. Whoops, spelling. The factored terms. And ladies and gentlemen, you have successfully converted a parabola from standard form into vertex form. What we can do just by looking at this bear, this is in vertex form, we now instantly know that the parabola went left 4 units because of the plus 4 right there, and then he went down 9 units because of this bear. So the new vertex is at negative 4 comma negative 9. Now, there's no doubt in my mind that those last 4 minutes sounded like they were in Chinese. There's no doubt about it. And usually the first 2 or 3 examples we do with completing the square go a bit over our head, but then we gradually build some confidence and get the hang of it. And then all of a sudden something clicks, and it goes from being impossible to fairly easy. And so I want to challenge you here with this next example. We're going to follow our notebook very specifically here. We're going to try to convert this equation right here into vertex form. So step number 1, I'm just going to rewrite it so that there are 2 spaces in between the B and the C term, just like so. Okay. Step number 2, I'm going to try to fill in those spaces with a special number, aka completing the square. Trying to complete the perfect square here, so to speak. The trick says we're going to take half of your b term, which is negative 6. So half of that is negative 3. If I square it, I get 9. So I'm going to add and subtract 9. Essentially, I'm adding 0 by the time I combine those two blue numbers. Step number 3, I'm going to factor the first 3 terms now. So I've got y equals x minus 3 times the quantity x minus 3. Good news is they're identical, so that's a good thing. And then I'm going to combine these last two terms right here into negative 7. And then last but not least, I'm going to condense those two factored terms. And I get this bear right here, and it matches up nicely with choice number 1. So the vertex, if they ask for the vertex, I would say that the vertex is at, let's see, we went to the right 3 units and we went down 7. So the vertex is at positive 3 comma negative 7. Well, here's our last one for tonight. We're going to practice, we're going to practice what we've been doing in Part A. And then I'm going to introduce you to a new trick in Part B that you'll find quite handy. But we'll really build some confidence throughout class tomorrow. The first couple might be a little shaky, but we'll talk it out, we'll work together, and we'll definitely get through it. Step number 1, I want you to rewrite this equation so that there are 2 spaces between the B and the C terms, okay? Plus a space, minus a space. Notice that's the same first move every single time. It doesn't get too tricky. This is a very methodical process. It's going to be the same steps every time. Step number 2, here's what I want you to do. Go back and read those notes, okay? Talk yourself through it. Right now my B term is negative 2. I need to take half of that, which is negative 1, and then I'm going to square that number, which turns out to be a positive 1. So I'm going to add 1 and subtract 1 to that equation. Step 3 is I'm going to factor those first 3 terms, and I need to come up with, as I'm factoring here, I'm thinking I need 2 numbers that add up to negative 2 and multiply to positive 1. And that's going to give me negative 1, negative 1. Again, those are identical. And then what I'm going to do is I'm going to combine those last 2 terms to get negative 9. Step 4 is I'm just going to simply condense those 2 factored terms. Whoop, 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 whoop. Almost wrote a 2 there. Whew. That would have been bad. That would have been bad. Okay, minus 9. And that right there is my answer for Part A. They wanted me to rewrite the function in vertex form, and now they want me to identify the coordinates of the parabola's turning point. So I would say we went to the right 1 unit, and then we went down 9 units. And that's my new vertex right there. Okay, now for Part B, they want me to find the x-intercepts algebraically by setting. They're telling me set the equation equal to 0. So I'm going to do exactly what they told me to do. I'm going to set this equation that I just developed equal to 0. X minus 1, quantity squared, minus 9. I'm going to set it equal to 0, okay? Now, there are certain things. You may be tempted to FOIL it out because of the squared sign, and that wouldn't be the worst idea in the world, but I'm going to show you a new trick that helps you avoid foiling, okay? And it's going to be a pretty slick trick. The first thing I'm going to do is I'm going to add the 9 over to the other side. Certainly a legal move. There's nothing illegal about that. The next thing I want to do is I want to try to kill this little squared sign. And in order to kill a squared sign, we take the square root of both sides. And so the square root and the squared cancel each other, and I get the quantity x minus 1. Parentheses are not needed anymore. Now, believe it or not, when you do the square root of 9, there are 2 solutions. There is positive 3, and there is also negative 3. So there's 2 solutions. I want you to put a little plus or minus sign in front of that. Last thing I'm going to do in order to get this x by itself is I'm going to add the 1 over to the other side. And believe it or not, there are 2 solutions. X equals 1 plus 3 gives me 4, and x equals 1 minus 3, which is negative 2. So I just found my 2 x-intercepts with a new method, and it all started with finding the parabola in vertex form. So I hope you got those shifts down, and I hope you have an appreciation for completing the square. We'll definitely practice it a ton more, and if we're a little bit confused with completing the square, it's not the end of the world. We'll use our notebooks tomorrow, and we'll fight our way through it. So good luck, and we'll see you.